Okay, so I am recording now. I'm going to stop video and share my screen. Okay, so what I did was I took some of the questions I wanted to do and I went ahead and I put them in my notebook paper so we could work them together. So let's get started with this first one. Now, this first one, this is the one that's not on your quiz. Reason being was some of your answers, and it's not that it's super complicated to solve. Honestly, it's really not that bad. But some of the answers are pretty long decimal answers, and I was playing around with the question in MATLAB, and if you don't keep enough decimal points, throughout all of your calculations, it's not very kind if you're even one decimal point off, which I thought was kind of ridiculous. So like I said, I kind of played around with it. I put in an answer purposely that was one decimal point off and it counted it wrong. And I was like, you know what? That's just going to cause a lot of problems especially for a quiz. So I didn't put this one on there. I figured we could just do it together. But the other ones we look at will be on your quiz. Okay, so on this one, let's read it. So I have a certain automobile. M of x equals this equation here. And it has an interval. And notice the interval isn't in interval notation. It's in just inequality form. But guys, notice the inequality has the less than or equal to. Well, sorry, I kind of just, now you can't see. Okay. Notice it has the less than or equal to, which means the left endpoint of this interval at 30 and the right at 60 are included. So you guys, this is another way, to note that your interval is closed. So when I see this problem, I see a closed interval from 30 to 60. So as I go through the problem, I'm going to consider that I have a closed interval. Now let's see what it's asking for. It's asking for the absolute max and the absolute min, and the speed at which it occurs. So you guys, because it's asking for both variables, it's asking for the x and for the y. The x is actually the speed. So notice up here, we're in x miles per hour. And then the miles per gallon, that's going to be the y. So this is x and this is y. But remember, you have to find, when you're looking for x and min, just make sure you know that you're finding x values. And then we will find the y's, but we need to find the x's first. Okay, so I have an equation. I have a closed interval, and I'm looking for absolute max and absolute min. So remember, on these closed intervals, when you're looking for your absolutes, because your endpoints are included, you are going to test your endpoints, both of them. But I also need to test any critical points that might lie within this interval. So the first thing I need to do, and I'm going to copy down the function here. You know what? I feel like my pen is writing a little thick. Let me see if I can fix that. Oh, I can. Okay. So I'm going to write the function again, just so we have more room to work. We have negative 0.015 x squared plus 1.23 x minus 7.6. So I need to find critical points first. So the first thing I do is take the first derivative. All right, so we're going to use some power rule. Now this negative is going to come along. You guys, when I bring this 2 down and multiply it by 0.015, I'm going to get 0.03 x plus 1.23. So this is my first derivative. I know I need to set this equal to 0 to find critical points. And then I'll just solve for x. Now this one's pretty easy. It's an easy solve because notice we only have x to the first, so you just have to isolate the x term. So we're going to subtract 1.23 from both sides and get negative 1.23 equals negative 0.03x. So now I just need to divide both sides by negative 0.03. So I'm going to do this. And I'm going to get my value for x, which is going to be the location of my critical point. Oh, that's nice. This one actually turned out perfect. You guys, this iteration of the problem with these particular numbers ended up being a whole number, 41. The last couple that I did were just horrible decimals. So I guess I picked a good example. I'm checking it one more time because that seems crazy. No, it's definitely 41. You guys, so your x value of your critical point is 41. Remember, and we only have one critical point on this one. So I just need to take this 41 and make sure it lies within my interval from 30 to 60. You guys, if it didn't, and I did not have a critical point in my interval, all I would do is test 30 and 60. But because 41 is in my interval from 30 to 60, I now have to test 30, 41, and 60. Okay, so remember where to test on a closed interval. You guys, I am finding the y values for these three x, and at the end, I'm just going to take the largest y value is going to be the max, and the smallest y value is going to be the min. So remember, if you're looking for y values at certain values for x, you always just put it in the original function. So this is a characteristic of these closed intervals. We test endpoints, we test any critical points that are in the interval, and we put them into the original. So let's test the 30. We'll have negative 0.015 times 30 squared plus 1.23 times 30 minus 7.6. So let me see here. I can't believe this. I just talked about how these were all crazy decimals and MATLAB was super strict about it. And then I give you an example that has whole numbers. That's okay. 30 squared times 0.015. So you guys, this is negative 13.5 here. And then plus 1.23 times 30. So plus 36.9. And I have minus 7.6. So then I just add and subtract here. So let's see. Minus. So you guys, here I get 15.8. This is the y value at x equals 30. Now let's do it all again with the 41. So I have that times 41 squared this time, 1.23 times 41 minus 7.6. So 41 times 41 times 0.015. This value is negative 25.215 plus 50.43 minus the 7.6. So then do your add and subtract. Here I got 17.615. And none of these values have had to be rounded so far on this particular problem. Oh, hold on. So on this one I have, why in the world? Okay, on this one I have negative 0.015 times 60 squared plus 1.23 times 60 minus 7.6. Let's see what we get here. So 60 times 60 times 0.015. So you guys, oh, sorry, I'm moving things. You guys, here I get negative 54 plus 73.9 0.8 minus 7.6. Minus 54, 7.6. And I get 12.2. All right, so remember why we are putting them in the original. All I want to know is which y value is highest and which y value is lowest. So to get y values, again, that's why I put them in the original. Now I'm going to make my decision. So you guys, this is the lowest y value. So that's an absolute min. So I even copied down the where you put in your answers on this one. I don't know why. But you guys, the absolute minimum miles per gallon. Remember, miles per gallon in this problem is the y value. So the absolute minimum y value is 12.2. And this occurs at the x value of 60. The absolute max y value here is the 17.615. And this occurs at the x value of 41. So we found our minimum happened at 60 and your maximum happens at 41. And then the 30 is just somewhere in the middle. So again, this one is not something you're going to have to do because I didn't put it on the quiz because, like I said, crazy rounding. But I wanted to show you an application of a closed interval and how to tell if it's a closed interval. First of all, it'll definitely say things like absolute max and absolute min, but also these or equal to's is equivalent to these brackets. So you know your interval is closed. Okay, so we did that one. Let's move on to the next one. You guys, this one, there is a similar question on your quiz, just like this. So let's read it. It says the velocity of a particle in feet per second is given by v equals t squared minus 9t plus 6, where t is the time in seconds for which it has traveled. Find the time, so remember time is an x value here, at which the velocity, the y, is at a minimum. On this one, notice there is no interval at all, you guys, so we will have to assume that our interval is open. Now, just because of this context of the problem, I know that time isn't negative, right? We don't usually have negative seconds. So I know that really I kind of do have an interval from 0. You know, time starts at 0 and then it goes up to infinity. But notice this is not a closed interval. You guys, this would just be an open situation. So if I don't have to worry about an interval, all I'm looking for is a minimum of this function. You guys, where do mins and max happen? They happen at critical points. So on this one, I need to find the critical points and find which one is a minimum. So how do I find critical points? Well, I take the first derivative, right? So we have v equals t squared minus 9t plus 6. Let's take the first derivative. That's going to be 2t minus 9. Set that equal to 0 to find your critical point. There will just be one. Notice because your derivative is just t to the first, it's just linear. Add 9 to both sides and you'll get 9 equals 2t. Divide by 2. And you get t equals 9/2. And I would just leave it as 9/2. I guess you could make it a decimal if you want, but I would just leave it this way. Okay, so this is the critical point. Here's the thing. I have to see if it's a minimum. We can't just assume. So you never want to assume, oh, I found a critical point. It's probably the minimum. We need to test it, because what if I test this and it happens to be a max? Well, that would mean there's no minimum of this problem, and my minimum would be none. So always test. Now, I will say, most of the time you will get the minimum that you're looking for, but I want you to test it anyway. Remember, we have two different methods to test critical points. We could put them on a number line and use the first derivative test, where I test values on either side to see if it's increasing or decreasing. But guys, unless something specifically says use the first derivative test, I would just use the second. So the second derivative test means we need the second derivative. Remember, so go from here and take the derivative of that, which is just 2. So when your second derivative is constant, notice it doesn't have a t in it, so it doesn't really matter what you put in for t, your second derivative is always positive 2. Remember how the second derivative test works? You take your t value, or whatever your critical point is, and you stick it into the second derivative. You stick it in there wherever t is in this case, but there is no t to stick it in. Remember, constant function means your second derivative is always 2. So when t equals 9/2, what is your second derivative? Well, it's still 2. So you guys, when we do use the second derivative test, whether we can put the t in there or not, or whether it's constant or not, what we're looking for is if it's positive or negative. So you could say, I put t equals 9/2 in there, and what I got out was a 2, a positive 2. You guys, when you put your critical point in your second derivative and it is positive, that means your graph is concave up. Positive means concave up. Concave up looks like a bowl. And it means that because your graph is concave up, this critical point would have to be a minimum. So I did confirm that t equals 9/2 is a minimum. So that would be my answer. So I've confirmed it. I can say yes. T equals 9/2 would be your answer there. What if, and I can't remember on this one, but so I get the 9/2 or 4.5 or whatever you want to call it. What if I actually needed to know what the minimum velocity is? Remember, if I need the y value, or in this case, the v, at t equals 9/2, you just put it in the original. When you're looking for a y value at a certain x, you always put it in the original. So let's do that. V equals 9/2 squared minus 9 times 9/2 plus 6. This one's kind of a yucky one just because of the fractions. But I know how to square fractions. Square the top, square the bottom, and get 81/4 minus, remember this is 9/1, so minus 81/2 plus 6. But if I really want to put these together, I need common denominators. So I'm going to do 81/4 minus, let's get a 4 on the bottom here. So that'd be 162 on top. How could I write 6 with a 4 on the bottom? Well, I could write that as 24/4. And then I could just add all these fractions, add or subtract. So let's see, 81 minus 162, we're at negative 81. Hold on. It's arithmetic, guys. It's not my strong point. I always second guess myself. So 24 minus. So we're at negative 57/4 as your velocity. Which seems weird, but that's okay. I don't actually think you have to find this value, but just in case, and it's good practice for other ones. I feel like velocity being negative is odd. Because velocity is speed. Could you be at a negative speed? I mean, I guess as long as we didn't do anything wrong, it's fine. It might just be a problem that doesn't actually make sense in the real world.
It's like when you're going in reverse.
Yeah, okay. I guess maybe we're going in reverse. Interesting. Oh, well. Well, we got it. You guys, we're going in reverse. Anyway, let's move on. But you guys, just before we move on, summary of this one. You're looking for a minimum velocity. Just find the critical point. Because there's no interval on it, you just find it and you just make sure it's a minimum. If for some reason the velocity, it wanted to know the max, well, you would do the same thing. You would find the critical point, and hopefully when you tested it, it was a max. This one actually doesn't have a max, does it? So if that was the question on this one, we would have to say none. Okay, let me get rid of it. Okay, so let's look at this one. When an object is dropped straight down, the distance in feet that it travels in t seconds is given by this function s of t equals negative 16t squared. Find the velocity at each of the following times. So now on the last one, it started with velocity, but in case you don't know, when you're talking about things moving, S is the position function, so actually where it is at any given time. So if the original function is S, you take the first derivative, that's the velocity. So basically, remember how the derivative is just how something is changing? So your position function S, well, how is your position changing? Well, that's your speed or your velocity. The difference between speed and velocity is velocity has a direction. But anyway, you guys, if you took the derivative of velocity, what you would get is acceleration. So this would you could either see it as the second derivative of S or the first derivative of V. But just in case that doesn't make sense when you see the velocity and acceleration, you start with S. First derivative is velocity. Second derivative is acceleration. Because if you think about it, guys, acceleration, if velocity is like speed, acceleration is how your speed is changing. Okay, so anyway, S, V, and then A. So let's look at what it wants. It wants the velocity at each of these times. So in A, B, and C, you're going to use the velocity function and just evaluate it at 2, 7, and 9. So let's find our velocity. So we have S of t equals negative 16 t squared. So your velocity, V of t, remember that's just taking the first derivative of S, is going to be negative 32 t. So that's a really easy one, guys. You're going to evaluate velocity at 2, which is going to be negative 64. See, we're getting a lot of negative velocities. You're going to evaluate your velocity. Well, it makes sense on this one. Oh, anyway. You're going to evaluate your velocity at 7. So it'd be negative 32 times 7. Ooh, guys, I can't do that one in my head. 32 times 7. 224. So negative 224. And then you're going to find the velocity at 9. So you'll do negative 32 times 9. And that is negative 288. So that should be pretty easy. You guys, part D says find the acceleration. So remember the sequence here. It goes from S, first derivative is V, second derivative is acceleration. So to find the acceleration, you're going to go from velocity and take the derivative of that to find acceleration. So the derivative of negative 32t is just negative 32. So it's just a constant function, but that's what you would put in, just negative 32. Or whatever your question is. That one actually might not change, because that's pretty standard for an object dropped straight down. Anyway, so this is probably the easiest question in the quiz. You guys find the velocity, find it at these places, and then take the derivative once more and get the acceleration. All right, so let's check this one out. The cost of a computer system increases with increased processor speeds. The cost C of a system as a function of processor speed is estimated with this C equals 5s squared minus 3s plus 1,000, where S is processor speed in megahertz Find the processor speed for which cost is at a minimum, and then round if necessary. I think you do have to round on this one. So again, think about the velocity where we were minimizing that before. This is kind of the same idea. I'm going to find a critical point and I'm going to make sure it's a minimum. Okay, so I have C equals 5s squared minus 3s plus 1,000. So I need to take the derivative of that, you guys. That's going to be 10s minus 3. Set this equal to 0. Notice I didn't give you any crazy ones with a lot of factoring. Not yet, at least. Add 3 to both sides and get 3 equals 10s. Divide by 10 and get s equals 3/10. Or because notice it says the rounding and the nearest tenth, your answer on this one will be a decimal. So I'm going to call that 0.3. So you guys, this is your critical point. Hopefully it's a minimum. Let's test. You guys, how do I test? Well, I find the second derivative. The second derivative of this is just 10. So very similar to the velocity problem that we did. Our second derivative is constant and positive, which means your second derivative is always positive. So you want to put 0.3 in there? Cool. It's still going to equal positive 10. So again, we're looking at a concave up situation, and that guarantees that your critical point is a minimum. We confirm it. So that would be your answer. Is this the last one? I think this is the last one. Okay. So you guys, on this one, I am looking for the point of diminishing returns for the function below. So point of diminishing returns, you guys, what am I looking for? Well, remember, this is a second derivative. A point of diminishing returns is an inflection point. How do I find inflection points? I set the second derivative equal to 0, and I see what comes out, right? Okay, so because you see point of diminishing returns, you know that your only goal on this one is to take the first and then the second derivative, set the second derivative equal to 0. That's going to give you your point. So let's see what we get. Let's take the first derivative. Now, this derivative might throw you off a little bit because notice we have a constant in front, and that's not our usual form. If you want to move the constant to the back, if that's confusing, you can. You don't have to, guys. Remember, you still can take the derivative of each thing at a time. So the derivative of the constant 10,000 is just 0. Then we have the derivative of negative x cubed. So that's going to become negative 3x squared. So notice, be really careful. If you do want to move that 10,000 to the back, make sure the negative stays with the x cubed. So I have negative 3x squared plus 2 times 39 is 78x plus 700. So let's get rid of that 0. Negative 3x squared plus 78x plus 700. Now, do I look for critical points? No, nowhere in the problem does it say anything about a max or a min or critical points. I don't care what the critical points are. What I do care is what the inflection points are. So from the first derivative, just go through and take the second, which is good because it means you don't have to factor this, right? But anyway, let's take the second derivative. So bring the 2 down in front. We get negative 6x plus 78. Okay, so set the second derivative equal to 0. Solve for x. and get negative 78 equals negative 6x. Divide both sides by negative 6. You guys, I think that's 13. And we get x equals 13. So this is your x value of your inflection point, or your point of diminishing returns. This question does ask for the y value though. So this is your x value. We need to find the y value now. So remember, if you're actually looking for just a y value, you put it in the original. So I'm going to do r of 13. And that's 10,000 minus 13 cubed plus 39 times 13 squared plus 700 times 13. So let's do all this. So I have 10,000 minus 2197 plus 39, 6591 plus 9100. Then I just do all this. So I'm just going to put all this in. 10,000 minus 2197 plus 6591 plus 9100. So I got 23,494. So I think you put this one in as a point. Notice right here, it shows you're looking for an XY point. So your X is 13 and your Y is whatever this is, 23,000 something. So there we go, guys. If all of these questions made sense to you, then you're going to be ready for your quiz, with the exception of the first one. Remember, that one wasn't on there. I guess I should have put it on there. Maybe yours would have been whole numbers too. Oh, well. So yeah, as long as all this makes sense, you look at the problem, you understand what to do on each of them. Know when you need the second, when you need the first derivative. And I think you'll be good, guys. Remember, your quiz is open through Monday. So that gives you a chance to finish any homework and then take the quiz. I mean, you can do it in whatever order you want to, but if you're worried about being prepared for the quiz, that homework will help you too. It doesn't have these applications, but it has the methods on there. So yeah, hopefully this kind of makes you feel good or better about the quiz. Notice, like I said, there's no crazy factoring. You really didn't have to factor at all to find critical points, which I kind of made a point to make it like that because this was about applications. I just want to know, can you read a word problem and know what method to use? I test you plenty over the factoring and the more complicated problems in your homework. So let me stop share. So yeah, so that's all I got for you. And this is recorded, so you can always go back and yeah, as soon as Zoom processes it, I can get it up there. Yeah, so you can go back and look at it before you take your quiz. But yeah, guys, I don't have anything else for you today, so I will just see you guys on Monday, and good luck on your quiz.